So now the user can type in their name as long as we create all the characters for the alphabet and any other characters we want to include. But now how about controlling things in our game? So right now if we run our program, we have our mushroom that just kind of coasts down the line. What we're going to do is we're going to remove that coasting and we're going to manually bind that to different keys on the keyboard. We're going to manually bind that to our arrow keys, up, down, left, and right. So we're going to use the same code that we have here, but instead of modifying the text value inside, we're going to modify the background image, or not the background image, the mushroom image.destRec, and we're going to move it by X speed and Y speed. So basically, we don't want it to anymore. We don't want it to move on its own anymore. We're going to comment out all this code. So down in our logic down here, actually let's do up here so we can see everything. So we're going to say if input.isKey released. This time it's key event dot vk underscore. Well, let's start with the up key. Make it move up. That means we have to change the y value because y value controls up and down. So basically, we're going to say mush image dot destrec dot y is equal to the same thing where it currently is, and now we want to change the y value. So we have our y speed. We set it to something up above. Doesn't matter what it is. We're going to use that variable. And now that y speed is going to indicate how far it should move every single time I hit that key. Now remember, when we're moving up, that means we need to go in the negative direction of y, because y gets bigger as it gets smaller. So what we're going to do is we're going to subtract y speed as opposed to add it. We just save our program. Oh, the problem is that y speed is a float, so we need to cast that to an integer, and then we're good to go. Now if we wanted, we could just change y speed to an integer and we wouldn't have to do that and we wouldn't have a problem. But let's make sure our code works right now. So we're going to save it, we're going to run our program. Move this over, click on here so I have focus. Now if I hit the up arrow, we should get a movement. We don't, so let's go investigate what the value of y speed is. We're debugging here. Oh, there's our problem. Y speed has a value of 0. Pretty slow. Let's move that, let's change that to say 2 pixels. So now we run it again, and if I hit the up arrow, now we're getting some motion. But if I'm holding it down right now and it's not moving, imagine playing Super Mario and every time you wanted to move to the right, you had to tap the right arrow. That'd be pretty useless. It'd be tap, 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 just to get to the end of the world. You should be able to hold it. Well, that is handled in how we capture the input. Right now we're capturing the input on a release, meaning every time we release the key, do an action. Well, that doesn't make sense for a game like this. Key release makes sense for text entry, but not for a game like this. So in this case, when we're trying to move, we want to see whether it's just, is it currently down or not? Is it currently being held? Key release could work for like a jump key or a fireball or something like that. But in terms of a button that we want to hold, we don't want to use is key released. We want to use is key down. Oops. Oh, that should do it. Good. So is key down. So now if I run my program, now I'm going to hold it and you'll see it move. Oops, I got to click on the blue. You'll see it move nice and smooth and cleanly. I don't have to tap, 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 tap or anything like that. It'll just continually move. Now we can do the exact same code, copy and paste this for all the other 4 directions. So we have up, let's do down, left and right. Now for down, we're also changing the y, but instead of subtracting, we're going to be adding. For left and right, we're not going to be modifying y, we're going to be modifying x. So we're moving left, we're still going to subtract x speed. but we're going to be adding x speed when we're moving to the right. That should be a plus. So in theory, with that simple change, we should actually have full control with our arrow keys over our mushroom now. Come over here, I can hit up. Oops, I got to click on the blue. I can hit up. I can hit down. I can hit, oh, what's my right value? Oh, my right value is super, super low. So let's move our right value. Let's move this at 2 as well. They don't have to be the same number, but for my demonstration purposes, I'm going to make them the same number. So I can move up, I can move down, I can move right, I can move left, and if I hold both keys at once, I can get diagonal. The only reason I can do this is because I'm using separate if statements. That means it's going to check for all 4 arrow keys no matter what. If I decided to make this an else statement, else if, else if, else if, it will still work. Come over here, I can move, I can still move up, I can move down, I can move right, I can move left. The problem is if I press 2 keys at once, one key always takes priority. Whichever key is higher up on the if-else if structure, because remember, it always goes into the first one that's true. I can't go on diagonals anymore at all. And once it goes into the first one that's true, it skips all the rest. So it's all in this priority order. So I have to be very careful about the way I set that up if I want to use an if-else if system. Sometimes it may be important, sometimes it may not be. It depends on the type of mechanism you're building at that given game time. So that's how we can add control into our individual items within our game using the keyboard. Next up, we talk about the mouse.